In topic 2, we're going on to the quadratic formula. If you took the equation ax squared plus bx plus c equals 0, which is the standard form of the quadratic equation, and then you solved it for x. And remember, the first thing we would do is to divide everything by a to get rid of the a, and we would bring our c over to this side. And there's a series of steps, and actually I have a video that outlines that. Eventually you end up with the quadratic formula, where you get x equals this. So that's where we're going, using this quadratic formula to solve some of these equations. Key to using the quadratic formula is that our original equation needs to be set up in standard form of the quadratic equation. And the reason for that is you have to identify your a value, your b value, and your c value to put into the formula to replace these letters. Now, it was solved from this formula, so these values reflect that it must be in this order. So as we look at example 1 here, is this equation in standard form? And the answer is no. So what do we need to do? Well, put it in standard form. So 3x squared plus 11x. Now transpose the 4 minus 4 equals 0. Now you can identify your a term, your b term, and your c term. And now we'll substitute. So x equals a negative b. So b is 11, so negative 11 plus or minus the square root of. Now, b squared will be 11 squared, which is 121, minus 4 is in the formula. A, we said, was 3, and c is a negative 4. And that's all going to be over 2a, so 2 times 3 is 6. So we'll give you a little time. You have to do this computation, and we'll see where it goes. So under the radical, we get the square root of 169, that you may recall is a perfect square. So this becomes negative 11 plus or minus 13 all over 6. Now you're going to get 2 answers. Let's see what you get. So a negative 11, negative 13 gives you a negative 24 over 6. That will reduce to a negative 4. And this reduces a negative 11, positive 13 is a positive 2 over 6 to 1/3. Now, anytime you get answers like this using the quadratic formula, it indicates that this could have factored. So let's see what we get here if we try to factor it. Now remember, factoring is a way too. So this is going to be 3x, and this is going to be x, and this is going to be a 4 here and a 1 there. Okay. So our signs, we want a positive, so this is a positive 4, and this will be a negative there. Now if we FOIL this, we get this. So here, x transpose that will be a 1/3, okay, and this x is equal to a -4, and these are the answers that we have. So, our first example. Now again, we're asked to use the quadratic formula. So as we look at letter B, is this in standard form? No. So we need to do so. So let's clear parentheses. X squared plus 3x equals 6x minus 9. Now we need to bring everything over to one side to put it in standard form. So we'll give you a moment to do that. And once again, why are we doing that? So we can identify our A term. There was no value before the x squared, so it's a 1. Every term has a 1 in front. And our B term is -3. And our C term is +9. So we now go to the quadratic formula and substitute. X equals a -b. Now if I put a negative of a -b, that's going to make it a +3. Plus or minus the square root. Now b squared is just 9. This term always becomes positive. Minus 4. A we said was 1. And b is 9. And this is all going to be over 2 times 1, which is 2. Okay, take a moment to do some calculation. We want to find what's under the radical sign. So we have a -4 times 9 is -36. Plus 9 leaves us with a -27. Now this is the square root of a negative number. So let's work that over here. The square root of -27. Now we're going to take out the square root of a -1, which is I, the square root of 9, and the square root of 3. So 3 times 9 is 27. So the square root of 9 is 3. So this is going to be 3i, the square root of 3. So that's what we have under the radical. So our answer then is going to be x equals 3 plus or minus 3i, the square root of 3, all over 2. And if you check your answers below, that's what they have. Now, keep in mind that every once in a while, when you get a negative under the radical, these would be imaginary numbers. Now, theoretically, this is not written in the correct form. As a reminder of what we did earlier, it should probably be written this way: 3 over 2 plus or minus 3, the square root of 3 with the I out there, over 2. But I believe this is what MathLab will accept. In example C, they're showing the quadratic equation in function notation. So we write it out: 4x squared minus 5x minus 2 equals 0. So again, we want to identify our A term, which will be 4, our B term, -5. Remember, when your B term is negative, As it goes in the formula, since it is negative, it makes it a positive. And then our c term is negative 2. So let's substitute. X equals 5 plus or minus the square root of. Now 5 squared is 25. It's always going to be positive. Minus 4. A is 4. And c is negative 2. And that's all going to be over 2 times 4, which is 8. Okay, give you a chance to work this out. This one was a little easier. And we note that when you see a negative, and there's a negative term for c, that this eventually will become positive. So 16 times 2 is 32, plus 25 is 57. And that's the answer. So this one was a little bit easy. Again, you have to identify your A, B, and C. Carefully substitute, do the calculation, double check it, and then your answer. Now, for this one, it's just a little tedious. We're saying that this equals this. So let's set that up. 4 plus 3 over x equals 5 over x squared. Well, to get us started, I think we could just take these terms and bring them over to the other side. So this is going to be 5 over x squared. This becomes a negative 3 over x. And this becomes a negative 4. And that equals 0. So from an earlier module, we want to get rid of our fractions. So we're going to multiply every term by x squared. And when we do so, this becomes a 5. This cancels out. This becomes a negative. One of the x's cancel out, 3x. And this becomes a negative 4x squared. Now, what I'm going to do is multiply every term by a negative 1, change my signs. So this will become a positive 4x. And when we do, it looks like this. And why did we do it? Because we have to put this in standard form so we can recognize our A term, our B term, and our C term. Now let's put it into the quadratic formula. X equals negative b, which will be a negative 3, plus or minus the square root of b squared, which would be 9, minus 4, a, which we said is 4, and c, which we're saying is a negative 5. And all of this is going to be over 2a, which is 2 times 4 is 8. All right, let's give you a moment to work on this. So we end up with a negative times a negative. This will become a positive. It's okay to do that change. So this is 4 times 5 is 20 times 4 is 80, plus 9, 89. And that's our answer. Okay. Now, for these, when we got answers above, we got exact answers. Anytime we had a radical, and we wanted to get a numerical approximation, we would have to put those values into a calculator, and that's what they're asking us to do here. So, as I look at example A here, I'm looking at my first two terms, and again, this is not factorable, but I'd like to use as a practice a skill we just went over, completing the square. So if you would with me do it this way. So we're going to put x squared plus 8x, take our c term, move it over here as a negative 10. Put a set of parentheses, and then we're going to find out what our new c term would be to make this a perfect square trinomial. Well, we know we have an x plus what? Well, it's half of our b term, which would be 4. So when we square this term, we get our new c term up here, which will be 16. And we have to add 16 to that side too. So we now have this equals 6. So when we take the square root of this side and plus or minus the square root of that side, we get x equals, transpose that 4, negative 4, plus or minus the square root of 6. Now, if you did this in the regular way, you'd get that same answer using the quadratic formula. But here it lends itself, I think this is much easier, by completing the square. So you would take these values, put it into your calculator, and you're going to approximate to 3 decimal places. And for this one, the answers are written down below, but we can put them here as well. X will be a negative 6.449, or X is a negative 1.551. Now in letter B, as we look at it, does this look like a good candidate for completing the square? And the answer is no, because of this fraction. Remember, you'd have to divide everything by 2, and we did one like that. Very tedious. So here, the quadratic formula would come in very handy, identifying your A, your B, and your C. It's in standard form. So we have x equals negative b. When b is negative, it becomes a positive because of the negative in front. So this is going to be 4 plus or minus the square root of b squared is 16 minus 4, a is 2, c is a negative 5, all over 2a, which is 4. All right, let's see what you get. Work that one out. So notice we had 2 negatives that we can make a positive. 2 times 5 is 10, times 4 is 40, plus 16 is 56. And this would be an answer you could use to calculate. An interesting point, though, about the 56, that is actually the square root of 4 times the square root of 14. And the square root of 4 then is 2, the square root of 14. So here, if you were doing it and just wanted the quadratic formula, you would have to simplify this. It would be like 4 over 4, that would be this 4 over this 4, plus or minus 2 the square root of 14 over 4. This part would become a 1. This is plus or minus 1/2 the square root of 14. So they're not asking that here because they just wanted numerical values, and this would be enough to get your numerical values by putting that in your calculator. But this would be sort of the super simplified version of it. Now, in Math Lab, you might say, which one do they want? Well, again, as you do your practice and your quiz-mes, you get to see the kind of example that you're going to get and then how to put it in Math Lab. Okay, we'll be going on to our next topic shortly.